How to wire a cooling fan relay. The venerable radiator cooling fan has been a mainstay in automotive cooling systems for many years. Gone are the days of the fan clutch, except in certain applications. Most vehicles manufactured after 1990 do have a cooling fan and relay. A relay is used due to its ability to absorb voltage spikes and shorted circuits. Relays are strong components with many years of being put to the test. The value of this section is to inform you of how to wire an entirely new cooling fan relay in the event that your fan motor of relay box has been damaged beyond repair. Oftentimes the fan motor is no longer available and a new universal fan motor is needed. Here we'll show you how to wire the cooling fan relay in a single and dual speed configuration. For drivers in cold climates the slower cooling fan speed is desirable. We should also mention that for our explanation we'll be using a cooling sensor switch. Cooling fan switch closes the circuit to engage the cooling fan when the optimum temperature is reached. The cooling switch, also sold in a universal format, is used to trigger the relay coil and actuate it as such. In turn, the relay activates the cooling fans. Only one cooling temperature switch is needed for the entire systems to work. Finally, cooling fan switches are sold in various formats, such as ground feed or pass-through. The pass-through is a simple switch or a screw-on sensor with two wires coming out. The ground feed has only one wire and is grounded at the body. To analyze this circuit we'll start with the following. There are two relays and temperature switches seen here. You may very well just wire the relay above the high-speed circuit by itself. However, we have included a second circuit here as a low-speed control for drivers in colder weather. Here current flows from the 12-volt source, through the fuse, and into terminal 30 of the relay. Terminal 87 is wired to the low-speed resistor. The other side of the resistor is wired to the motor. The fan motor is permanently grounded to chassis ground. Terminal 86 is fed 12 volts directly from the fuse, so this makes the circuit ground actuated. In other words, the temperature switch outputs a ground, which is fed to terminal 85. As soon as the engine reaches a said temperature value or around 180 degrees Fahrenheit or 85 degrees Celsius, the fan kicks on. The other half if this circuit is the high-speed relay. This is meant as a means to cool the engine down when conditions are very hot or to prevent overheating. This circuit is also useful as an air conditioning condenser coil cooler. Current flows through the fuse to terminal 30 of relay number 1. Terminal 87 is also connected to the fan motor power input, spliced right with the other power wire. There is no feedback here because terminal 87 is normally off. Terminal 86 of relay 1 is connected to power at the fuse. Terminal 85 is where the trick is. Terminal 85 is connected to one side of the temperature switch. The other side of the switch goes to the output of the other relay. In this configuration one relay feeds the other as a backup. If the second relay or the low-speed one goes defective, then relay 1 does not work. The second leg of the high-P temperature switch can also be connected to ground to make it independent or to an air conditioning ground output to work when the AC is turned on. This configuration was chosen to make it easier to diagnose if a future issue arises and to show various forms of wiring this circuit.